I'm going to talk to you about the digital radio amateur workstation. I'm going to kind of cover why digital radio. I'm going to cover what this particular draw system is, how to use it, and then hopefully hey Jason, hopefully I can have a demonstration using it. And just in the process of using it, I've kind of learned some advantages of the system. But without further ado, first off, you got to go to the first part is why digital radio. And hey, Jason, just starting. Didn't miss anything yet. What's digital radio for? And now we talk about digital radio involves a computer somehow or a very smart radio. I think you could look at and think about Morse code and RTTY as being really the first digital modes, for lack of a better term. You're not using voice, you're using sound. So, why digital radio? And I mentioned you kind of look at the lineage with CW and RTTY and forms like that. And now we're at more advanced forms, but they all have the same advantage. They can handle weak signal propagation, i.e., you have low power, you have non-optimal antennas, or you have non-optimal conditions, band conditions. You can have simultaneous conversations on a single frequency, which means the calls are going to overlap on each other on one single frequency without interrupting the other conversation. You have clear, precise communication. I didn't say concise, but it's precise because you actually have letters and the system does error checking. So you know whatever's being transmitted is being received correctly. More advanced, you can send scanned documents. For example, you know, an emergency situation, you need a prescription or like Dave talked about, an approval form for budgets or get equipment shipped. You can actually scan a document, get a signature, scan it back, and send it over digital modes. And of course, again, it kind of goes through that disaster prep thing. You can send pictures. You want to show an area of destruction or whatever else, you can send it over the digital modes. So some of you guys, this is your setup for digital radio in the early years. You've got your standard voice radio. You've got it hooked up to a computer. And then you've got the computer. Between the two is some kind of modem, some kind of device that takes computer audio or computer requests and puts in audio format that the radio can transmit. And this is essentially how digital radio works. Like I said, a lot of it's built into the computer or in the radio itself, but that's what's happening. So here is DRAWS. And this is a Raspberry Pi hat. And for those that don't know what a Raspberry Pi is, it is a little single board computer. It's about that big. And this sits on top of that. So it's a hat. It sits on top like a hat. I'll kind of talk about it a little bit later, but just overall what it has is this is a GPS antenna input. This is the GPS receiver itself. This is your audio connections that can run 2 radios. And then inside you have a bunch of other nice bells and whistles to do the rest of the work. And if I cut out, please remind me. Okay, so what is that thing I just showed you? Like I said, it's a hat, a Raspberry 3 compliant. It should work on a Raspberry 4, so that means a Raspberry 3 or 4. You should be able to plug in and work out of the box. It supplies power, so you just give it 12 volts, and the reason I bring that up is the Raspberry Pi is designed to take 5 volts USB power. The hat can take standard 12 volts, like what you have for your regular radio setup, and will create power for the Raspberry Pi off that. So it makes it a little easier to use in field conditions. It's got 2 radio interfaces, like I said, 2 radio interfaces, 2 audio interfaces, essentially, using mini DIN connectors. In my radio, the Yaesu, it just plugs directly in. And I think most radios are like that. You get a little bit older radio, and you start having to make your own connections. Like I said, it has onboard GPS using an external antenna. So that's important because if it used an internal antenna, you'd have to be careful where you mounted it. But as it is, I can stuff it in the middle of a box, and it does just fine as long as I have the external antenna connected. The the PPS for Stratum 1 time source, that means it's getting a uh, part per second interval from the GPS clock, and it's creating its own time signal. So first off, the Pi itself has a very good time sync, which is important for digital modes. But secondly, it shows up as a MPT time source, like your computer automatically knows what time it is and when to change the clocks, right? Well, that's the NPT. That's the, and Mark can explain what that acronym is, but essentially that's a time source. So if you have this Pi on your network, it can be the time source. And again, think about a field condition that you have to have digital radios, have to have a time sync. And Dave and I struggled with that, and we had to do manual time hacks, entering exact moment that we hear the WWV. And this will automatically sync everything on the same network. And the real-time clock is battery backed up. So if you do lose the GPS signal momentarily, you still have that constant time signal. So everybody's in sync. So overall, I kind of mentioned that the DRAWS hat, the overall DRAWS system requires the hat, a Raspberry Pi or 3 or 4 with software, and the external antenna. That is the complete DRAWS system. And I'll kind of take you through the next part. I don't remember what I had in these slides. Capabilities, this system I'm talking about, this box with these items in it. You can do packet modes, you're familiar with those, i.e. APRS, as well as sound card digital modes. All your HF stuff, anything FLDG does, WSJX, everything that does, and WinLink connections. There is it does talk about, it has capability for digital voice. There is some software with a D-Star on it. I don't understand what it's for. It seems like it's more towards if you're going to hook this up to a repeater system. And that other set of connectors you might have seen in the picture, that's really for connecting to a repeater type setup. I don't have a repeater, so I haven't looked that much into it. All right, so I've talked about this piece of hardware and digital radio, et cetera. So how does it DRAWS do? What is it doing? For my elevator selling point, it is a self-contained box to handle the HF and VHF, UHF communication digital modes. It is the audio interface, it's rate control, and it does all the encoding and decoding of data. So that is all you need to do digital modes. Now, caveat, I said no digital computer needed, no signal link or equivalent needed. All you need is a radio, sort of. And I kind of get into that. But essentially, the whole DRAW system is one little box. So here's the two ways you can use it. Headless, which means it's not connected to keyboard or monitor. I'll kind of talk about that in a second. Or WorkStation, it is the entire computer. So you bring your monitor with you and your keyboard. So headless mode, that's how I'm going to use it. And that's how I'm using it right this second. That screen you saw when you're checking in, that was the DRAWS Pi running via VNC'd into it. So that's the Pi screen. So on the Pi right now, nothing's attached to it except for the GPS antenna and the radio. So that's headless mode. No keyboard, mouse, or monitor. Some of the device controls it like a tablet. I said perhaps a tablet, and I've actually tried it, and you can use a tablet to do all the same things. So think about that. Your deployment box is that and a tablet. And just need to be plugged into Pi DRAWS. So that's why I said it's sort of all you need. So you have to have the radio, and you have to have some way to communicate to the DRAWS system. This is how I run it, and this is what I was showing you. This is the headless mode. So I'm using VNC software. And if you use a Raspberry Pi at all, you are probably using the VNC software to control it. It's just a remote desktop, and it comes installed automatically on most of the Pi distribution software, including this one. So this, and not the background, that's my screen, but this in here, this is what the Pi would be showing if you plugged it into a monitor. So I have full control of everything on the screen. But also, it runs a web server, and there's some things that run via that. And this particular example is how I contact WinLink to do email, essentially, WinLink email. And this, you can see, is can you see my mouse? I guess not. There you can. This is the web address on the Pi that this page of the WinLink is. And so I just have to go through the buttons, and I can send and receive WinLink email as well as compose it. Now, for those who do WinLink, this does not do the standard messages that WinLink Express does. So this would be workstation mode, and this is actually my box that I'm just about done working. But I have hidden in the middle is the Raspberry Pi. I have a wireless keyboard attached to it, and then this monitor is attached to it. So this would really be all I would need in just this box for my particular setup. Or, like I said, if you don't have a monitor with you, just the Pi and a tablet of some sort. Hardware, I talked about that a little bit. The additional pieces I didn't mention, here's the battery backup clock. This is the interface for other radios, i.e. a repeater, and this is the power input. This is my box, never mind the fancy carving. There aren't many Raspberry Pi boxes made out of metal that are actually big enough to hold the Pi hat, this Draws hat on top of it. So I found one, which is actually even too big, but it got the job done. Unfortunately, it's such a tight fit that I had to, you know, how do I word this? Bit by bit, slowly etch away, trying to make a hole for the stuff to fit. I couldn't just lay it in there, mark it out, and then cut it because it wouldn't fit. I had to cut a hole before it actually fit enough for me to cut more holes, if that makes sense. But this is how I have it set up my radio, just purely by accident because it just fit that way. But it became important because there's a micro SD card in case I need to swap it out or something. If this is buried, I'd have a hard time getting that back out. That's GPS antenna, mark GPS. How about that? 12-volt input. I just found a barrel connector I had and used that. Side view, I'm showing the two audio inputs. The standard for the Draw software is the left, and it talks about left and right for your audio inputs. So mine radio is attached to the left, and so the software understands what the left radio is, and you can have two radios. It can differentiate between the two and send different commands as far as the transmission, the PTT signal or other things to the different radios, depending on what you want to do. I think that'd be a little bit too complex for what I need. But theoretically, I could hook my Kenwood up to it for APRS while I'm doing digital modes on the Yaesu.
Mike, was that a metal box or is that a plastic box?
That's a metal box.
Okay.
Yeah, plastic box would be easy. But I wanted the RFI shielding just in case.
Okay, I wasn't sure. I buy a box set of fries, and theirs are all plastic. They're cut around boxes. I wasn't sure what that is. Okay, thank you.
On that subject, I did read some people took regular plastic boxes and they lined them with aluminum foil or some kind of aluminum sticky tape, and that seemed to do the same job. I just happened to find that particular box that wasn't too expensive. So Draws as it is, and I'll kind of show you what information is available for the setup. There is a disk image. You write to the card, you stick it in, boot it up, but you still have to go through a setup process. It's very well written, and the folks working on it have spent a lot of time. So it's set up so you put in your call sign and any other things you have to personalize it to you, and it loads all the software around it. It goes through an entire script of loading software. So it isn't preloaded exactly, but once you run the setup script, then it's all set up for all the basic things. The one thing that wasn't set up and really wasn't documented very well is radio 1-in-1. If you want to see how much power your radio is putting out, if you just click the mic, you're not going to get accurate signal, right? You're not going to get accurate representation of how much power you're putting out. You need some kind of input into it before you get a RF out. And so I first started running it, I was getting nothing out of it. It was triggering the transmit, but nothing was going out. I could tell because the power meter wasn't moving. So I actually show now a different mode on my radio, but I was using this, which is what the Yaesu owner manual says to display to see if it's actually getting an input to send out to the RF circuits. And right now, this is how it looks normally now that I have it set up. But initially, once I found this menu, the this bottom line was the only thing being lit up. So there was nothing coming into the radio to go back out. And so that part wasn't well annotated. Luckily, like I said, very supportive group on their Groups.io page. And I found out by accident there that a feature that I didn't know about is another web page running on the Pi the entire time called the Draws Manager. It does a few things, but the important thing it does is set your levels. And these are not my current levels. It was just a screenshot before I got it running. So this allows you to set your levels, but even then, it's like, okay, what do I set? There's a calculator, but it only works if you know what the radio requires for input. And I couldn't find anything listed for mine. So talking back and forth to the writer, he's recommended I just set up, put the radio on low power and have an HT in here in the office and just put on the same frequency on an off frequency. I was doing this over VHF. I was on off frequency on 5 watts, and I didn't take a screenshot of it, but there's just a little command in this software package that will send a 2200 hertz tone to the transmitter. So it's transmitting a single tone. So just set your radio up there and just keep increasing the digital gain until you hear that tone correctly without overdriving it. The terminology you're using for analog gain, digital gain, it still doesn't make sense to it, but essentially the analog gain is data going to the radio. So the analog gain is the carrier going to the radio, and mine set at 0 now. The digital gain is this is how I'm going to describe it, and the software guy that wrote this describes it differently. But essentially, it's how much effort this Pi is going into creating the signal that goes out on the waves. And they call it dBs, but it doesn't make sense to call it dBs, but that's the way they wanted to use it. Anyway, I had to crank mine all the way up before it'd get an output. It was sending the modulation, but it wouldn't send the tone until I raised it all the way up. So that was the only difficult part other than setting up WinLink, but the WinLink setup wasn't part of the draws anyway. It was additional. I'm going to go one more slide, and then I'm going to show you what was available in the resource for setting it up. And so this is what I used. This is their Groups.io page, and that was my single source, except for the WinLink stuff. And that was KM4ACK, his YouTube page. And he had 3 videos on the subject. And I went to the first video, which was actually the second video that I needed. So I had to go to a later video he made, do that one. And there's like, oh, okay, that was the basic setup. And then I go back to the first video I found. Chronologically, the first video I found occurred earlier than the second video that I had to use. But regardless of that, that is all I needed to do to get the thing running for WinLink. I'm going to show you, let me get out of this thing. All right. So if you go to the Northwest Digital Radio Groups.io page, and you dig in, there's specifically one for the UDRC, which is the earlier version of draws. So they've been transitioning the hardware a little bit, but essentially it's the same thing. They have a wiki at the bottom, which leads to this page, right? Now, this gets a little bit confusing. You can tell the guy, he admits, this is Basil, N7NIX. He admits he's not very good documentation, but they did a real good job anyway. So you start this link, it says getting started, right? So I have my brand new image I downloaded from them, and I stuck it in, booted up. So that link takes you to this page. Now, getting started takes you to this page. And so that goes through how you set up the whole installation, the entire thing. Going back here, there's a test and verification page. And then guess what? That tells you how to test the AX25 stuff, some different tune things. But mostly this is around the AX25 that's working, and to see if your sound card part's working. All this stuff worked out of the box. There was never a problem with that. And that was all that their instructions helped. And then, like I said, it was the main page, the message page, where you post a question, and the software guy would answer within a day or so. And so that made this much easier to operate. And my final picture, and this is what I had actually. So this is, like I said, this is draws running on my Pi remotely. So I've remoted in through the desktop, and this is WSJTX running on it. And if you haven't used WSJTX, it does all these different types of digital modes, including Whisper. And I've found Whisper to be very useful. So I mentioned, I think I mentioned in the beginning, I found a side benefit of this whole thing is I have no setup. When I want to use a digital mode, other than set up the antenna, but if I want to use digital modes on VHF or whatever I've set up, all I have to do is power on the box because the Pi power is on. All the stuff automatically starts up, and I just open the window and start clicking what I want. As opposed to the setup I had for field day, I had my signal link and all this stuff plugged in my laptop. I had to boot up the laptop, make sure the signal link, everything came in. If anybody uses these things knows this. Made sure everything had the right COM ports, load all the different software packages for rig control and everything else, and then do the digital modes. This, I just turn the box on, hook up an antenna, and go. So for me, once I got past the initial learning curve of trying to figure out what they're trying to tell me, if you just read through the steps and do them like it says, it installs like it should. So me personally, I'm really enjoying it. I think it's actually a good investment. Some of the other toys I bought, I haven't used that much. This thing's been on doing stuff since day one. So I'd like to open to questions. I can go back to any of the slides or demonstrate something, whatever you guys want. This is your training. How much did it cost? I forget. Dave, do you remember how much it was?
150.
150. That's always the big question.
Okay, so I'm hearing the pies get pretty hot on the radio. So you have a fan on it blowing across it?
Good question. So that's my big concern, especially being in the box. There is a. I'll close this out for a second. So I've got this whole list of commands that I use to do stuff. And I think this one. Yeah. I'll show you. Like I said, these guys wrote all this stuff, so it's all there. It's just hidden. But this is going to show you right now what this thing is running. And there's no fan running on it right this second. And this, my office is actually kind of warm. So right now it's sitting at 59 degrees, 60 degrees. I have a little fan. I'm in the process of transitioning things a little bit still. But I have a little fan that's going to blow across it. And I was testing this with the fan blowing across it. And I never, with the fan on it, a little 80 millimeter fan. With that blowing across it, it was about 5 degrees cooler. It never got any hotter than 60. I never had any. These commands pop up if it gets over temped. I never got any kind of throttling or anything like that.
Is that the 5? I'm sorry.
This is a 3. The 4 is a different. Yeah, the 4 is a different story, and I haven't heard any long-term answers about that one. And this is a 4 case that has double fans on it. And the way the draws board is in there, there's no room for, barely room for a heat sink, definitely no room for a fan above the Pi 4. So I don't know if you can stack, maybe Mark could answer this, I don't know if you can stack those edge connectors to raise this hat higher up and put some air below it. I don't know if that'll make things worse, but that's why I'm not running a 4 on it. But I haven't needed it. There's plenty of horsepower in this 3.
Oh, you need to put the heat sinks on the Pi 3 and it should be okay.
This one has no heat sinks on it right now.
The 4 needs a fan.
Yeah.
Because it's running a lot hotter, a lot faster.
That's probably the one that I'm hearing the guys talking about on the radio there, that they're going, these things are hot. A lot of the guys were wishing they had the Pi 2 because it seemed to be cooler, but that's what I hear on the radio. I haven't invested in the Pis yet at all, so I wasn't sure, but that just tells you what's going on. Thank you.
Yeah.
Well, it's $150 for for the hat, and I think the Pi 3s are probably 35 or 40 still. I'm not sure. I think
Yeah,
that's what I paid for it.
they'll be giving away soon.
Yeah.
I know Jason's trying to figure out what he's going to do with his radio.
Well, I like what I'm seeing here so far. I mean, I have no experience with stuff like this, but would you say the documentation for someone that has not a lot of experience with digital was pretty easy to understand, or like kind of?
Right.
Right.
There was no. I'll far this back up again. There was no setup that I don't remember doing any kind of setup for the WSJTX. It just, once I followed the whole scripts, it just worked out of the box. You had
Wow.
to tell it. The only thing is you had to tell it. I don't remember if it asked or what I did because you remember I've gone in, I've done the WinLink part, which required a lot of manual entries. But I think it knew. You told it what radio it was and how it's going to connect, and and it assumes like if this radio is going to be a USB to serial device. And so I didn't have any setup for that. I basically just plugged it in. And right now, and I don't remember setting anything at all in the configurations. It just did what it does. It changed the channels right there. You can see you check a band and it's going to change the channel for you. So as far as WSGTX, there wasn't any work I had to do that. I remember FLDigi, some reason I think I might have had a setting to do, but it wasn't very much. And once you have it up and running, it's this listing. So I just fired it up and this is listening right now.
And so I know this is kind of like going backwards, but you have antenna to radio to the little draws box or whatever.
Yeah.
And then that's connected to, and then the Raspberry Pi can go like talk to the draws box. Is that what's going on?
Yeah, the draws box is on top of the Raspberry Pi. That's why I couldn't show it. It's wedged in the box. But it's
Okay.
on top of the Raspberry Pi. So it and the Pi are one complete package.
Mm-hmm.
So in my case, the radio is plugged into that. Well, in all cases, everybody's radio is going to be plugged into the audio port, unless you're like a run repeater. Dave's got an example. But there's a draws hat right there. So, and there's his Pi. So you can see where the two plug in there.
Where?
There's on the Pi, there's a header.
Mm-hmm.
In.
Oh, sorry, I didn't even see that Dave was there.
Demonstrating Vanna. So it just plugs in the Raspberry Pi. It's a standard, just plugs in the top.
It's called the GPIO bus.
So the draws plugs into the Pi.
Yes.
Yeah. That's why it's called the hat, because it sits on top of the Raspberry Pi.
Gotcha.
And that makes it a self-contained unit. And like I said, because the draws board supplies the power to the Pi, you can give it 12 volts like you're powering your radio from, which makes it much easier.
And sorry for another like total noob question here.
Over here.
But, the Raspberry Pi is basically a little computer and operating system, and what you're doing, like what we're seeing on your screen here, you're on just like your desktop or laptop computer, and you're using. I know what VNC is. It's like a remote desktop, and you're just doing a remote desktop into the Raspberry Pi.
Right.
From the Pi. So what you're seeing right there is the Pi desktop.
Okay.
If I plug the monitor, if I plug the monitor in the Pi, you'd see the exact same thing, no difference.
Okay, got it. I don't think I've ever played with like Raspberry Pi or anything like that in my life. So
the Raspberry Pi is a Linux-based computer, and well, I'm sure it runs other things for the really strange people, but the main distributions are Linux, but they're pretty well fleshed out. And like I said, you don't have to know Linux to do the basic stuff. You follow the commands and it loads everything in. Linux is required to do some of the deeper stuff, but even then, it's not like Mark Koros Linux. It's like, very simple stuff, and it even shows you type this thing in, hit the enter key.